Quick question. Have you ever checked your phone and thought, why is my battery dropping so fast? Or when you're walking to class and you realize you're running late, so you start walking faster without even noticing.
All of those moments have one thing in common. Something is changing.
And here's the cool part. There's a whole branch of mathematics that explains exactly how fast those changes are happening.
In this video, we explain what derivatives are, introduce you to differentiation rules, and show you real-life situations to prove that you've been actually using it in your day-to-day life without knowing it.
Let's get started.
So first, what exactly is a derivative? A derivative tells us the rate of change of something, how fast it's changing at a specific moment.
Like speed. Speed tells us how fast distance is changing.
Exactly. The process of finding a derivative is called differentiation. So, differentiation is the process, and the derivative is the result.
Now, let's explore the differentiation rules. First, we have the constant rule. The constant rule says that the derivative of a constant is 0. Let C be the constant. If f of x is equal to c, then the derivative is equal to 0. For example, imagine you receive a fixed 500 allowance every week. In this example, 500 is our f of x, but because 500 is a constant, no matter how time passes, the amount never changes. So the rate of a change is 0. Second, we have the identity function rule. If the function is equal to x, its derivative is always equal to 1. How do we solve this? Well, when differentiating x, we must subtract the exponent by 1. And we know that x has an imaginary exponent which is 1. So, we have x raised to 1 minus 1, which is 0. But wait, how do you solve x raised to 0? Well, x raised to 0 is always equal to 1. Therefore, the derivative of x is equal to 1. Take note, after differentiating a function, the notation becomes f prime of x, which represents the derivative or the final answer. However, while you're differentiating, your notation will be placed next to the function you want to differentiate, which is dy over dx.
Third, we have the power rule. In using the power rule, you multiply the exponent with the numerical coefficient, then subtract the exponent by 1. For example, we have f of x is equal to x raised to 5. You multiply 5 with the numerical coefficient. We all know that the variable x has an imaginary coefficient, which is 1. So, we multiply it. 5 times 1. Afterwards, we subtract 1 from the exponent 5. 5 minus 1 is equal to 4. The answer now is f prime of x is equal to 5x raised to 4. Fourth, we have the constant multiple rule. If a function is multiplied by a constant, we keep the constant and differentiate the rest. Let's try an example. F of x is equals to 5x raised to 4. Write 5 as the constant, then multiply it to the derivative of the equation x raised to 4. So, we have 5 times 4x raised to 4 minus 1. Simplify 5 times 4 and 4 minus 1. Our answer now is f prime x is equals to 20x cubed.
Fifth, we have the sum and difference rule. The derivative of a sum or difference is the sum or difference of the derivatives. That sounds confusing, I know, but to put it simply, you will need to differentiate all the terms first, then add or subtract them after. For example, we need to differentiate the function of x raised to 3 plus 3x minus 6. Differentiate all the terms first, so we have f prime of x equals derivative of x cubed plus 3 derivative of x minus derivative of 6. So we have f prime of x equals 3x squared plus 3x raised to 0 minus 0. But wait, how do you solve x raised to 0? Well, x raised to 0 is always equal to 1. So basically, just have to multiply 3 and 1. So we have f of prime of x equals 3x squared plus 3 multiplied by 1 minus 0. Then simplify, our final answer is f prime of x equals to 3x squared plus 3. 6 is the product rule. The product rule is used when two quantities are multiplied and both are changing. In the product rule, we have the variables u and v. U refers to the first quantity and v refers to the second quantity term. To solve this, you have to multiply u and derivative of v, and multiply v with the derivative of u. Afterwards, you add all the terms together to simplify. For example, f of x equals quantity of 4x plus 5 times 3x. In this equation, u is equals to 4x plus 5 and v is equals to 3x. So we have f prime of x equals quantity of 4x plus 5 times derivative of 3x plus 3x times derivative of 4x plus 5. So we have f prime of x equals quantity of 4x plus 5 times 3 plus 3x times 4. Then we multiply f prime of x equals 12x plus 15 plus 12x. Then we combine like terms, 12x and 12x. So our final answer is f prime of x equals 24x plus 15.
Next, we have the quotient rule. The quotient rule applies when one changing quantity is divided by another. It is somewhat like the product rule where we have the variables u and v, but this time, u represents the numerator and v represents the denominator. The formula for the quotient rule is the derivative of u over x is equal to v times the derivative of u minus u times the derivative of v all over v squared. So to solve for this, you must first multiply v with the derivative of u and then subtract the product of u and the derivative of v from it. That will be for the numerator, whereas for the denominator, you simply substitute the value of v but leave it be. You do not solve for the denominator. In this case, it's v squared, but you do not square the denominator. Let's try an example. F of x is equal to x squared plus 3 all over 5x minus 4. First, we need to identify u and v. So u in this case is x squared plus 3 and v is 5x minus 4. Then we plug in the values of u and v into the formula. So the derivative of x squared plus 3 all over 5x minus 4 is equal to 5x minus 4 times the derivative of x squared plus 3 minus x squared plus 3 times the derivative of 5x minus 4 all over 5x minus 4 squared. First, let's find the derivative of x squared plus 3. As we know from the power rule, we have to multiply the coefficient with the exponent, and the exponent you subtract by 1. So x squared, 2 is the exponent and 1 is the coefficient. 2 times 1 is 2, copy x, and 2 minus 1 is 1. We don't need to write 1 as the exponent. Next, we'll derive 5x minus 4. The derivative of 5x according to the constant multiple rule is simply 5. Next, we distribute 5x minus 4 and 2x. So 5x times 2x is 10x squared, and negative 4 times 2x is negative 8x. Then we distribute x squared plus 3 and multiply it to 5. So x squared times 5 is 5x squared, and 3 times 5 is 15. Take note that when solving for the quotient rule, always put a parenthesis on the second quantity, because in the next step, we would have to distribute the negative sign into the quantity. So our numerator now is 10x squared minus 8x minus 5x squared minus 15. Up next, we combine like terms to simplify. The like terms in this equation are 10x squared and negative 5x squared. So 10x squared minus 5x squared is equal to 5x squared. And we copy negative 8x and negative 15. So our final answer now is f prime of x is equal to 5x squared minus 8x minus 15 all over 5x minus 4 squared. And with that, our video comes to an end. We hope you learned a lot from this little tutorial. Don't forget to like, share with your friends, and subscribe. Thanks for watching!